For problem number 37, it says determine whether y is a function of x. And they say y squared equals 3x minus 7. Now you might have gotten stuck on that, trying to figure out you might have gotten stuck on that because you probably. I gotta start the video over because
you just showed all our names.
No, not that. And no, because it'll take too long. All right. So retake. Problem number 37 asks us: is y squared minus 3x minus y, is that a function? Okay. Now probably we said first of all, how do we determine if something's a function or not?
Oh.
Yes.
There can only be like one y value for one x value.
Yeah. So So there's like one. He said one unique. I'm going to use a little more formal definition, but there's one unique output per input. And so remember, if we do a mapping and I have an x value here, I can only have one arrow going to the corresponding y, right? That's a function. If I have two arrows, won't work, all right? How do we tell that if we had the graph? Yes?
The vertical line test.
Another way we could determine this is what we call the vertical line test. Okay, so if we have the graph, we draw a vertical line. If it crosses more than one time, not a function. How do you graph that on your calculator? Yeah, so here's the challenge. Our calculator does this little deal, right? And it doesn't have a thing called y squared. Well, you could solve it algebraically, right? That's one way to do it. But let me show you how to graph it. Yeah, let's do it. Let's do it algebraically. So he said, hey, why don't you algebraically take the square root of both sides? Well, all right, let's do that. If we take the square root of both sides, in other words, if I take the square root of this and the square root of this, I'll get y is equal to, now remember, it's plus or minus the square root of 3x minus 7. So that means I would say y sub 1 is equal to the positive root or principal root of the square root of 3x minus 7. And then y sub 2 would be equal to the negative square root of 3x minus y. That's one way to graph it. Okay? Hey, that's the graph yx squared, or I mean y squared.
It's not a function.
Yeah, it's not a function. Just relax. Let me finish my sentence, but you're correct. I'm glad that you realize that. If we do the vertical line test, boom, crosses twice, not a function. All right, so it's not a function. Now let's try it the other way. We algebraically solved it, and we said, well, basically, we could take the square root of 3x minus 7. Oops, wrong one. Right? And then we had to take the negative square root of 3x minus 7. I know what it is. I don't need your help. And then I got to turn the stat plot off. So let me turn that off. I was using that the other day. And then let me choose, we'll choose a standard fit. All right. Same graph, right? And if I go through here, and I do the vertical line test, it crosses here and here. So again, this is not a function. Does that make sense?
Yep.
All right, cool.
So is graphing really the only
Graphing's not the only way, so how would you do that algebraically? Well, here, guess what we would have? If I plugged in a value for x, right, I would get one mapping. So let's plug in a number, all right? Let's make x equal 3. Well, if that's the case, then this would become 3 times 3, which is 9 minus 7,
2.
which would be 2. So this would be the square root of 2. So when x equals 3, it maps to the square root of 2. Now let's do the same thing down here, right? This would be the exact same number here, except it'd be the negative square root of 2.
So it'd be 2 different.
So you have 2 arrows.
Oh, okay.
See how that works?
Yeah.
All right.
Yeah.